Then patients will start to compensate. They've been uncompensated because the bicarb is not responding quick enough to the CO2 level. The CO2 level is not responding quick enough to the bicarb. And now the body's starting to kick it up into high gear and starting to try to fix things. And you will start to see compensation. And usually it starts with partial compensation. But the thing that we're looking at, we can't tell if it's partial compensation until we evaluate everything, right? pH is what we start with again, 7.35 to 7.45. Again, for our acidotic or acidemic states, we would expect them to be low. For the metabolic alkalemia or respiratory alkalemia, we expect that pH to be increased, greater than 7.45. Once we've evaluated that, we then look at the CO2. So when we look at the CO2, let's look at metabolic acidemia first, the first line. When we look at the CO2 is to be pointing downward. And you're realizing the bicarb is the problem. So what is happening with the bicarb? The bicarb is dropping. It's going in the same direction as the pH. With metabolic alkalemia, our pH is high, greater than 7.45. And then the bicarb we notice is high. So we have a metabolic alkalemia, we notice we have a high bicarb, and then we're going to compensate by trying to make a more acidic environment with the CO2. Same thing with the respiratory alkalemia. When you see the pH in a certain direction and both your CO2 and bicarb are off, you have to figure out which one is actually pointing in the right direction for the acid versus the alkali state, and then the other one is a compensating factor. So for instance, like in the first line, we would say this is a metabolic acidemia or acidosis with respiratory compensation. In that third line, we would say it's respiratory acidosis or academia with metabolic compensation.